Okay, so we ended up here, Cartesian form, Cartesian coordinates or Cartesian vectors. I'll start with that one and we'll quickly finish it and then go to the tutorial questions because we haven't done this part last time. We just started, we didn't do much. So I hope you remember here when you have coordinates. So any vector has a starting point and an ending point, and it has a direction. So you can put it in a Cartesian plane, that means in an XY plane, so XY plane, and you can show it like this starting from the origin. So the ending point coordinates, if it is 2 and 3, the 2 means along the X direction, you have to go 2 units, and along the Y direction, you have to go 3 units. So that means we can represent this vector in the Cartesian form. Cartesian form means this something times I plus something times j. So if you can write it like this, we call it Cartesian form. So this I and j are unit vectors. I is the unit vector along x. Unit vector means it has a direction, specified direction along the x, but the magnitude is 1 unit. And along the y direction, we have the unit vector j, which has a 1 magnitude, and the direction is along the y. So in this one, we can write this OA vector as 2 times I plus 3 times j. So this form we call the Cartesian form. Any question up to here? We already discussed this. Okay, so whatever you have in front of I, that is our x component. And whatever you have in front of the j, that will be your y component. So do you guys agree with that?
Yeah.
Okay. And when you have the Cartesian vector, you should know how to find the magnitude and the direction. So you can find the magnitude. Magnitude means the length of this blue line. So you can find it using the Pythagoras theorem. So blue line, that means OA vector. For the magnitude, we use this absolute sign. So you can find that one, which is 2 squared plus 3 squared square root of this one. So that will be the magnitude of this vector. If you want to find the direction, so this is the direction, angle making with the x-axis or else angle making with the y-axis. So normally we consider the angle making with the x-axis. So you can write the tan theta. Tan is opposite over the adjacent. So you can find the theta, which is tan inverse 3 over 2. So now with this one, you can see when we have the vector in the Cartesian form, we can convert it to the magnitude and the direction. Am I right? And also we have already know how to find when you know the magnitude and the direction, you know how to find the x component and the y component. We did it on Tuesday so that you can convert, when you know the magnitude and the direction, you can convert it to Cartesian form as well. So that's where we stopped last time. Do you guys have any question up to here? Are we all okay? Do we have anyone who were not here last Tuesday? I don't think. So I hope you all are okay with this one. So that's what we have here. So the magnitude is 3.6 unit and the direction is 56.3 degrees from the positive x-axis in the counterclockwise direction. So this is the counterclockwise direction. We already discussed those things. Okay, now let's see. Let's move on to the next one now. So we already discussed this one. Yeah, so this one, we can do this. So when the Cartesian form is known, we can find the magnitude. When the magnitude, the direction is known, we can find the Cartesian representation of the vector. So that part is done. Okay, we did this question as well last time. So I'm not going to do this one, but we have some questions in the tutorial. So we are going to do that tutorial questions. Okay, so let's do this, please. If you can remember. So where this one is, if you want to represent this in the XY coordinate, can you try to do this one? So your X coordinate is 5. So that means where that point is, and Y coordinate is -7. Can you try by yourself? So do you have your vector like this? Is this right?
Yeah.
Okay. Now how can we find the magnitude? Magnitude of this vector, which is force, magnitude of this force, which is equals to 5 squared plus 7 squared minus 7 squared minus, when it is squared, it will become positive. So square root of this, and you can find the magnitude. If you want to find this angle theta, you can find the angle theta. Tan theta is equals to opposite, which is this length, which is 7 divided by 5. So theta is tan inverse 7/5. Is that right? Please talk. Otherwise, I don't know whether you have understood or not.
I'm getting it. I'm not sure if anyone else is there.
Yeah, it's only Scott's talking. How about others?
Yeah, all good.
Okay, that's good. Okay, now if you put those in the calculator, you get these values. So the magnitude is 8.6 newtons and the angle is 54.45. But if you see the angle, it is clockwise direction from the positive x-axis. So we need to mention, I told you last time, it is very important to write the answer in words correctly. So this from the positive x-axis, this is the positive x-axis. From that, it is this many degrees in the clockwise direction. So you need to write it properly. I hope you are okay with that. Now let's see how to subtract vectors. So it is important to know how to subtract. So here you have 20 newtons towards the right and 15 newtons towards the left. So if you have to add them, so when you add them, you do the same thing. Even this is two vectors. So you start at a point and you go 20 newtons towards the right. You are here now. Now you need to draw 15 newtons towards the left. So you go 15 like this. So this is your end. So start to end will give you this is your resultant. So this we call the resultant. Resultant is equals to 10 newtons towards right. So we follow the same method. We draw the vectors start to end, head to tail, and start to end distance will give us the resultant like we did for other vectors in the previous day. So we do the same thing. But if we have to minus vectors, what we need to do is so when we have to minus, let's see what we need to do. In the previous one, we added it. So when we need to minus, for example, 10 to north minus 6 to north. So I draw the 10 to north and I need to minus 6 to north. So whenever we have subtraction, what we do is we convert it to an addition question by changing the direction of the second vector. So we can make it to a addition question, 10 remains the same, and we make it to addition question. This 6 will be 6 newtons opposite side. Now you can do this, can't you? So how do? You start with here. This is my start. I go 10 units along the north, and this is 10. And then I need to add a 6 towards the south. So this is 6 and end is here. When you draw start to end line, that will give you the resultant. So resultant is 10 minus 6, which is equals to 4 newtons. I took very simple examples here, but your questions are not this simple. But when you understand these basics, the complex questions will be easy, because the method that you follow is the same, whatever the complexity we have in questions. So whenever you have a minus subtraction question, you convert it to an addition question by changing the second vector's direction to the opposite side. Is that make sense? Any question? Any question?
All good for me.
Okay, so. Okay, now I think we are okay. They are fine. Okay, so can you try this one, please? I'll give you a few minutes. 6 to the west. 6 to the west. Minus 8 to the north. So what will happen here? We can make this to a addition by changing the direction of the second vector. So we make it to a addition by changing the direction of this one. So how do you add these two together now? You draw them, you draw the vector triangle. So you can either start with 8 or 6, that doesn't matter. So let's start with the 6. This is start, and you go 6 units towards the left, 6, and you go 8 units down. Then this is your end. Start to end will give you the resultant. So you can, this is right angle triangle, so you can find the find this length using the Pythagoras theorem. So the resultant is equals to 6 squared plus 8 squared square root of this. You can find the angle theta, which is tan theta is equals to opposite over the adjacent. So theta is tan inverse 8 over 6. So you can find the direction, direction, and also you can find the magnitude. Are we good? So if you find the answers, that will be 10 units and 53.13 degrees from west to south. I hope you remember this one, west to south. West is this, south is this. From west to south, 53.13 degrees. Okay. Any question? If you don't have any question, can you please try this one? Subtraction of Cartesian vectors. Think can do it. So I told you we can add Cartesian vectors just by adding the x parts together and y parts together separately. I hope you remember that. Similarly, you can do the minusing as well. So can I give you a few minutes for you to try? When you finish, tell me your answer, okay? We have questions, okay? Even though I didn't give you time to do the previous question, similar question for the previous thing, when we go to the tutorial, I'll give you time to do the questions by yourself. That's the most important thing, doing the things by yourself. So how do we do V1 minus V2? So what we do is, these are the X components. So I'm going to highlight the X components. So these are the X components. U minus the X component separately and U minus the Y component separately. Then you get something times I plus something times J. So what is that thing inside the brackets? Here it should be 10 minus 2. Here this should be 6 minus 50. Does that make sense? So our answer will be 8i plus 21, isn't it? 21j. So V1 minus V2 will be this. In case if they ask you to find the magnitude and the direction, you find the magnitude and the direction. Because this is the X component, this is the Y component, you can find the magnitude using the Pythagoras theorem, and also you can find the direction considering the tan. Any question? Can I move to the next part?
Yeah,
Yeah,
go
all
for it.
good.
Okay. Done. Multiplication of vectors, we will do in week 7 or 8. Okay, so don't worry about it. For with that, we are finishing the content for the week 1. So let's move to the tutorial questions. Tutorial questions.
Sorry, Miss, will you be uploading this PowerPoint like this afternoon today? Only because I want to go through and do a bit more summary and revision before the weekend.
Yes, I will do that.
Awesome, thank you.
Is the tutorial a workbook?
Yes, there is a
Oh, cool. I've already done that.
do you have that? I just copied them in a PowerPoint because I can write and it is easier for me, but it is there in your workbook. Did you guys find it?
Yeah, I've downloaded a workbook.
Okay.
I don't know about anyone else.
Yeah, so you can find those questions, and also I'm going to put this one these ones in view so you can find it. So I don't think we need to go through this summary because we already know. So let's start with the questions. Okay, so they have given us few. This is your first one. I just copied and pasted it here. I don't want you guys to do everything. I'll give you a few questions and I want you to try these, please. Maybe we'll do this one. This one. This one, just 3, okay? They are a little bit different. Addition is fine with you guys. Here again, you are learning addition as well because you are converting it to addition question. So I'll give you a few minutes. Please try them and tell me when you finish. I will do after you try. How did you go with the first one?
Quick question.
Yes.
So this is from the Fundamentals Mechanics workbook.
Yes, yes.
Okay, because the copy I downloaded has different questions.
But similar, isn't it?
Yeah, they're similar, but I'm just saying, but obviously you're working from two different versions. The version that's uploaded is 2015 version.
Oh, okay. How about, can you check the other questions also? These ones are very, like,
Yeah,
even
they're similar, but I'm just saying, but like it's
yeah, I understand.
yeah.
How about these ones? Maybe these ones, do you have them or do you have different ones?
No, I've got that one.
Ah, okay,
Yeah,
maybe
that's
the first,
1.21.
maybe the first question, maybe the other
Yeah,
ones,
cool. It's fine.
this is also there, right?
Yeah, they're based on the textbook. Yeah, that's fine. Yeah, cool.
Or maybe the first question, which has many parts on that. So 6 to east minus 5 to east. East is this, right? So 6 minus 5. So what we do, we convert this to a positive by converting this to opposite direction. So we have 6 to here, 5 to here. So your resultant will be 1. 1 to east. Did you get the same?
Yes.
Okay, that's good. How about this? Did you finish this? Five to east minus 2 to south. Again, you can make this to a positive.
5.3.
Let me check. So 5 squared. So that will be like this. This is the resultant. So let me check. 5 squared plus 2 squared. Square root of the answer. Yes, 5.339 roughly. Yes, 38 or something. 5.38. To where? So this is right, units. To where? How do you find that? You need to find this theta, isn't it? So that tan theta, if you write the tan theta, 2 over 5. So 2 over 5, and we need to take it as 0.4. You need to take the tan inverse of this one. So I get 21.8 degrees. Do you get the same?
Yeah, I got the same.
Okay, so how do you write this as an answer now? From where to where this 21.8 is from where to where? From east towards the north, am I right? So how do you write it? 21.8 from east to north, and 5.3 units is your answer. So you write it like this. Am I right? Is that right? How about the next one? Did you finish it or do you need more time for that? How we do that? North 30 west means what? This is your north and this is your west. From
Swinging to the west 30 degrees.
yes, from the north to west it is 30 degrees and it is 8. then you need to minus a 10 to west. 10 to west means 10 to west here. So you can change this one to a positive sign by changing 10 to the opposite side. So you have a addition question now. How we do now? You develop the
Parallelogram.
vector polygon, isn't it? You can do the components if you want to. Otherwise, you draw the vector polygon, which is 10 to here and 30. 8 here. And start to end will give you the resultant. This is your start and this is your end. And we know this angle is 30. So this one should be 60 because it is 90. This is 90, isn't it? So this should be 60. Now you use what? Which rule? You know two lengths and the angle between the two lengths. So what rule you use? You use the cosine rule, am I right?
Yep.
Yes,
C squared plus C squared 2bc for the.
that's right. So when you do that, 10 squared plus 8 squared minus 2 times 8 times 10 times cos 60. I get 84. And when you take the square root of this, I get 9.16, maybe 9.17. Do you get the same? We need to take the square root of that to find the resultant. Do you get the same? Anyone got the same? Or if I'm wrong, let me know.
No, I got the same as well.
Okay, that's good. Now we need to find the direction. So maybe this angle. We need to use the sine rule now. So sine theta divided by the opposite length, which is 8, is equals to sine 60. We know this angle divided by the opposite length, which is r. We found it 9.17. So we can find the sine theta. It is 8 times sine 60 divided by 9.17. So you can find the theta taking the sine inverse of this one. So 8 times sine 60 divided by 9.17, 0.755. So I take the sine inverse of that. So I get 49 degrees. Do you guys get the same?
Yeah, I just did.
Okay, so how will we write this one now? From where to where? So our answer, when we write it, we need to write it properly. So 9.17 units. 49 degrees from where to where? From east to north. Agree? So this will be my answer. Any question? Can you please try the last one? It is a bit different. Last one, M, and we'll move to the next question. There, you can do the rest of the things whenever you have time, okay? Please do the last one. East to north 45. So that means east to north this way, 45 degrees. And that is 4 units. Then minus north to east 30. Eight. How do we do this one now? How we make it to a positive? You can make this to a positive by opposite direction, changing this to the opposite side. Am I right? This is 30, so this also should be 30, so you don't have this one anymore. You have into the opposite side 30 degrees, and that will be your addition. Is that make sense? Now you can draw the vector polygon, so vector triangle. So you are drawing this one 45. Then from here, you are drawing this one. It's like this. Am I right? This is 4 and this is 8. Maybe I'll make it a little bit longer because it is twice the length. And this angle is 30 and this angle is 40. Does that make sense? So this is your resultant R. If it is not clear enough for you to recognize this, I'll draw it again. Sorry. Drawing is very important, otherwise you can't figure out. So you are going 45 degrees, 45, and you are stopping here. So that is 4. And where you are now, you are here now. So you need to make 30 degrees from this vertical axis. So that means 30 degrees is less than 45. So you are going like this. 8. This is 30. And this is 40. And your resultant is like this. Am I right? So how you solve this? You need to know two lengths and the angle between the two lengths. Don't we know that? We know these two lengths. Do we know the angle between the two lengths? Do we know this? This angle here? What's that angle? It is 45 minus 30. Do you agree with me? Because this angle is 45. And you might need to minus a 30. So that will be a 15-degree angle. Agree? Please talk, guys. Otherwise, I don't know whether you understand or not.
Yes.
Okay.
Yeah, I get it.
Okay, so now we can use the cosine rule and we can write an expression to R. So it doesn't matter how the shape look like. We follow our method. We know the two sides and the angle between the two sides. So we write the cosine rule. R squared is equals to 4 squared plus 8 squared minus 4 times 8 times, sorry, 2 should be there. 2 times 4 times 8 times cos 50. So you put these numbers in the calculator. 4 squared plus 8 squared
4.26.
What do you get?
4.26.
For the square root?
Yeah.
Okay. So we got this. That's done. How do you find the angle now?
10.
Well, you have this, you need to
Oh,
find this
sine.
angle, isn't it?
Fine, sorry.
Sine rule. So you just take this as theta. So how do you write it? Sine theta over the opposite length, which is 8, is equals to sine 15 over r, which we found 4.26, isn't it? So you can find the theta. Can you find me the theta, please? So 8 times sine 15 divided by 4.26, take the sine inverse of that. What you get? Six. So sine inverse. I got 29 degrees. Do you get the same? So can it be 20?
I got the same as you.
Yeah, got the same. I think
20?
everyone else has wandered off to dinner.
29 degrees. So that means it's not happening this way. We have, it's how the triangle will look like this. Do you agree?
Yeah.
That's why we have 29, a small angle, 29 degrees. How do you write this one?
4.26 n
From where
e-
to where?
hmm?
From where to where? And how?
From 0, 4.26 east. So sorry, 4.26 n east
East to north,
29
east to north, not
east to north.
29, not 29. You need to
Oh,
minus
sorry.
from 45, isn't it? So
Yeah, sorry.
45 minus 29. Do you all understand what I am doing? This theta we got as 29. So that can't be, the shape of your vector triangle can't be this. So it should be like this because this angle is 29. And also this is 45. We already know this one is 45. So we need to minus the 29 from the 45 to find out from east to north.
That's 16 degrees.
Yes, so it is only 16 degrees from east to north.
So east 16 north.
East to north 16, yes. East 16 north, yes. Okay, so that is covering most of the things. So throughout your whole course, you are going to do this. This is what we have till till the friction part. You have the moment also similar to this one. Okay, I think you guys are okay with this now. So let's move on. So I have done some more questions. I'll put this PowerPoint there so that you can do your questions and try see whether you get the same answers. Okay, so we don't have to do all this. Okay, so next question is this. A link is subjected to two forces, F1 and F2. Determine the magnitude and the direction of the resultant force acting on the link using the parallelogram theorem method. So that means vector diagram. So we need to use the vector diagram or trigonometric method. They are not, otherwise the other method that we learned is the component method. They are asking you to use the vector diagram method, drawing the triangle. So show all working outs. Your answer is including full label. Okay. So can you draw the vector diagram for this one now? You start at a point. You can start either with 600 or 400. I'll give you a few minutes and you do it and let me know when you finish.
You already done this one. I got 629 newtons, 67.89 degrees. Yep, there we go. Bingo.
Sorry, I was mute. So anyone else got the same answers?
Yeah, I got that.
Okay, that's good. So I assume others.
Luke there. Oh, Luke's unmuted. Hello, Luke.
Hello. Yeah, I haven't done this one yet. Still working on it.
Okay. So how about you, Phil?
So pretty much it's just working through the rest of a workbook now, is it?
Yes.
Okay, cool.
We can skip the similar questions. We can go to the different questions. There are a lot, I think.
Is it all just is it just pretty much all of section 1 for this week, is it?
Yes, yes.
Cool. Yeah, there's tons of questions. I might pop off and just work through these on my own and just work through the whole workbook on
Yes.
week 1. And any questions, I'll email you.
Yes, yes, yeah, that's fine. Yeah. I'll put this one. And also you have answers. I think you can check most.
Yeah, there are other answers in the book.
Yes, okay.
Cool. Thanks a lot. See you next week.
See you.
Bye.
Bye. So look, you finish this?
Yeah, I'm just finishing it now.
Yeah. Let me know when you finish. We'll move on to the next one. How you go, Phil?
Yeah, I'm still working on it.
Okay, yes. Let me know when you finish. And if you want me to go through this one, I can go through again, okay? If you don't understand anything, let me know. I can go through again.
Alright, I got this answer now.
That's good. So how about you, Phil?
Yeah, I got it.
Okay, that's good. You don't have to be you don't have to rush, okay? This is the main part. If you do this one, if you understand this, that is the most important thing. Okay, this is very similar to the previous one, so we'll move to a different question maybe. This is very similar to the previous one. Okay. Okay, let's do this. So you have your vector diagram, two vectors like that, and they are asking us to find the resultant of this. Resultant is always going between the two. So it should be somewhere here, going at the middle. So we can draw the vector diagram similar to the previous one. Can you please try? We can draw the vector diagram starting from maybe 100 or 150, doesn't matter. 100 is making a 15 degrees from the horizontal axis, so it will look like this. Then you have to draw the 150. 150 is making 10 degrees. So this is 10 degrees. So it's going like that. Now the start to end will give you the resultant, which is this. So we have the triangle. Do you also have a similar kind of a triangle? It doesn't matter if you started from 150, your diagram will look like this. 10, and from here you have 15. And this is your end. Again, you have a similar triangle in the other direction. It's also right. So both are right. It's just the mirror image of the other one. So two of you, are you okay with drawing the vector diagram?
Yep.
Okay, so I just use one. So we know the two sides, and do we know the angle between two sides? That means this angle, do we know that?
I think I got it as 115.
Yes, how we got it? 115, yes, it is right. So how did we get it? So this is 10, isn't it? Because this is,
Yeah.
and this is 15, so this is 90. So if you add 90 plus 15 plus 10, which is
Yeah.
115, isn't it? That will be our angle. Okay, so we know the angle between the two sides as well. So we I have done something wrong here. So this is 150. So my answers are wrong. So we have to calculate and see. So you can now write the cosine rule. 100 squared plus 150 squared minus 2 times 100 times 150 times cos 150. So let me check. What do we get?
I got 212.6.
Yeah, I got the same.
That's good. Let me check. Yes, 200 and yes, 212.6 newtons. Now we need to find the angle. So this is 115. And this angle, if we can find this angle theta, we can write the sign for that, isn't it? Sine theta divided by opposite length, which is 150, is equals to sine 115 over r, which is 212.6. I got this as 0.6394 something. Let me take the sign inverse. 39.74. Do you get the same or have I done anything?
I used the other triangle, so I think mine's a little bit different,
Okay,
but I ended up getting 54 degrees from east to north.
so your one is like this.
Yeah,
So you find this angle, did you?
yeah,
So 212.6, and this will be your 10, and so this will be your 150, and this will be your 100. So you wrote your sine theta over 100 is equals to sine 115 over 212.6.
yep.
So your theta was what?
25.2.
So that is this one. So you need to add another 10 to make it from north to east. Did you do that?
I went the other way. I went from east to north.
Okay, east to north, you need to add 15. So, sorry. Sorry. So this is east to north. That means this one, you need to find this angle here. Am I right?
Yeah,
So that should be 90 minus 25.2 plus 10. Did you
Yep.
do that?
yeah, that's what I did.
Okay, so that's right, yes. So we should get the same, I should get the same, this, I need to add another 15 to this one. So I also should get the same number, so do
Yep.
both
Yeah,
get
that
the
looks
same?
right.
Oh, okay, so it is the same answer anyway. So are we good?
Yep.
So Phil, are you okay as well?
Yeah.
Okay. Okay, so that's done. So I think you are okay with this kind of questions. Whatever the shape is different, we follow the same thing. So this, your resultant is making 50 something. 55, roughly 55 degrees. No? So it is going somewhere here so that you can see this resultant, how it is going. It is going in between the two forces. Okay, these all are same. So we are not going to do everything again, but I want, if we have time, we'll come back. So I'll put this one, you can do it later on. So we'll do different questions. They're all okay. So let's do the same question. Same question using this one you already did. You did with the vector triangle method. Now, shall we try the component method? Do you guys remember the component methods? Or do you want me to do one question?
Yeah, can you just do one?
Yes. So we are
Thanks.
going to divide the vectors into component. That means x component and the y component. So we have these two vectors. X component means, so this is my x component, this is my y component. I just write this as x and the y. So if you look at, if you write the sine 30 is equals to opposite divided by the adjacent is 600 because this F1 is, sorry, the hypotenuse is 600 because this is 600. So divided by 600. So y is equals to 600 times sine 30. So this component, y component, I can find, which is 600 times sine 30. I can put the value in the calculator and can find it. And similarly, if I write the cos 30, cos is adjacent divided by 600. So I can find the x component, which is 600 cos 30. So is that clear?
Yep.
Can you try the other one? So you go like this.
Yep.
So this is your, I put it as y1 and y2 and x2. The previous one, I'm going to put y1 and x1. So now you write the cos and the sine, cos 45 and sine 45. So if I write sine 45 this time, what is sine 45 this time?
That's x over 400.
Yes, x2 over 400. So your x2 is 400 times sine 45. And if you write cos, that is y2 over 400, which is y2 is equals to 400 times cos 45. Okay, so you don't need to write these angles all the time. There is an easy way to remember this. So what is the easy way? So here you know the angle with the x-axis. So angle with the x-axis is known. So x component is cos. Always known side is cos. Here you know the angle with the y-axis. So your y component is cos. Do you see that?
Yep.
So you don't have to write this all the time because you are going to do this a lot throughout the course. So if you want to, till you get familiar, you can write it. Otherwise, you can remember it in a way that if you know the known side angle, the angle towards the known side is always cos. The other one is sine. So are we all good? Any question? How are you, Paddy? Okay, that's good. Okay, now up to here, do we have any question? So Phil, are you okay?
Yeah, I'm okay.
Okay, so now let's see. When we have a question like that, what we do is we make a table at the beginning, because then you won't go wrong. So we have two forces, 400 and 600. So we need to find the x component and the y component of both of these. So if you look at the 400 one, you have y component as 400 cos 45. And you have x component as 400 sine 45. Similarly, you already found the 600. So x component is 600 cos 30 and the y component is 600 sine 30. Now, we have to put the right sign. X is measured towards the right as positive. Y is upward positive. Now, can you tell me, for the 400, x component, is it positive value or a negative value? So I'm looking at this one here, 400 x component. Is that arrow towards the right or left, positive or negative? Positive x direction or negative x direction?
It's negative.
Negative. So this is negative. How about the y component? This one,
It's positive.
positive. How about the 600x component? This one,
It's positive.
positive. Y component,
Positive.
positive. Now you find the algebraic sum. You add these together. So you add these two together and you find the x component of resultant. And you add the y components together and you find the y component, resultant y component of the resultant. Can you find me this? Were you able to find it? Do you get this? Or have I done anything wrong?
Yeah, I think that's good.
Okay. Now, if you want to, now we'll revise our Cartesian part as well. So if you want to write, after you find the components, you can write the vectors in the Cartesian form. It's not asking this particular question, but if you want to write F1 as a Cartesian form, that means Cartesian form means something times I is the unit vector along the x direction and j is the unit vector along the y direction. So you can use these the components and write it. So you can write F1 in the Cartesian form as 519.61 I plus 300 j. Is that clear? Can you tell me how to write the F2? Or else F2 is my 400 force, this one. How can I write it? X component times I plus y component times j.
So it'd just be negative 282.8 I plus 282.8 J.
Yes, that's right. So that's how, if we have to convert this 400 force to a Cartesian form, some questions they're asking that, you just do this. If you want to convert this 600 into Cartesian form, you just do this. And if you want to write the resultant in Cartesian form, you can write the resultant force, which is equals to 236.8 I plus 582.8 J. So this is the Cartesian form of the resultant force. But in this one, we need to give it not as a Cartesian vector, we need to find the magnitude and the direction. So how do we find, if we know the x component and the y component, how can we find the magnitude and the direction? You go backward now. Before you knew the 600 and you found the coordinates, sorry, the components. Now you know the components, you're going to find the resultant force, magnitude. How can we do that? You draw the vector diagram. So this is a positive x. So towards the positive x side, you have 236.8. Towards the positive y direction, you have 582.8. So start to end will give you the resultant, which is this one. You don't need to use cosine rule and sine rule. You can use the Pythagoras theorem because this is a right angle triangle. So R is equals to square root of 582.8 squared plus 236.8 squared. Does that make sense? And you can find the angle as well, just writing the tan theta. So can I give you a few minutes for you to find the final answer for this question? Resultant magnitude and the direction. When you finish, when you find it, let me know. Okay, we'll check your answers with mine.
I think I got it.
Okay, let me check. Did you get 629?
Yep.
How about the angle?
68 degrees.
Yes. If you get 68, I have 90 minus 68. I think that's right.
Yep.
Yes. So you have from y to, from the positive, you have from the positive x-axis. I got it from the positive y-axis in the clockwise direction. You have from the positive x-axis counterclockwise direction.
Yep.
How about you, Phil and Paddy? Do you need more time? Okay, all right. If I'm going fast, tell me, okay, because so this one we don't need to do it. Maybe we'll do a different one. We did this. but we'll do a different one. Okay, let's do this one. Yes, let's do this. I'll give you a few minutes for you to do this. Or else maybe do this one. Find the coordinates of this. Sorry, components of this. So you have two forces. You have 800 and you have 600. I want you to find the x and the y. With the sign, okay? With positive or negative, whatever it is. When you finish, let me know. $800 is very easy. It is towards 8. So what is the x component of 800?
0.
Yes, it is 0. And this one is just 800. Positive. How about the 600? I told you when it is going towards, if the angle is towards x component is cos. If the angle is towards y component is cos. Here the angle is towards the x, so 600 cos is for x component and it is positive. Y component is a negative, am I right? It is 600 sine 30. Now we can add these together and we can find the resultant x and the y. So 600 plus 30. This is 519.6. And the next one is 800 minus 600 sine 30 is 300. So this is 500. Now we can draw it. 519 towards the x, positive x side, 500 towards the positive y. So this is 519.6. This is 500. So our resultant is like this. So you can find the resultant. Resultant is equals to 519.6 squared plus 500 squared square root of this one. So we can find that. It's 721. You get the same. I can find the tan theta 500 over 519. Theta is tan inverse this. I don't have the answer for this. So do you guys getting the same number? So my ones are wrong. I'm not sure. Tan inverse this. So I get 43.9 degrees. From the positive x-axis, in the counterclockwise. Do you get that or do you get something else?
Yeah, I got the same.
So I assume Paddy and Phil also got the same. If not, tell me. We can see where you went wrong.
Yeah, I got the same.
So now let's do few questions with Cartesian dimensions. So when you do the Cartesian axes, there is a define the positive x and y axes directions according to the following coordinate axis diagram. So this is your positive x and this is your positive y. So that's this is the answer for that one. Okay, so that you already know that. Okay, they are asking us to use this one and plot these numbers now. For each of the following vectors, what is the component of the vector in x direction and the component in the y direction? For each of the following vectors, sketch the vector on the coordinate axis diagram. For each of the following vectors, determine the magnitude and the direction of the vector. Okay, so let's take one by one. So I have the Cartesian coordinates here. So you can also plot something like this, x, y, and put that 1, 2, 3, 4. The maximum we have is 5. So 5 is enough. So can you just have something like this? We can work together. Just the two axes, x and y, and few squares like this.
Hey, I gotta go for dinner, but thanks
Yeah.
for tonight. I'll continue this on my own.
Yes, okay.
So
See you. Okay, in the first one, we have a positive 4 in the x. Whatever we have in front of I is x. Whatever we have in front of j is 3. So y component is 4 and sorry, x component is 4, y component is 3. So that point will be like this. Is that right? Now we can find the resultant or the magnitude of this vector. So you can find the magnitude, which is 4 squared, because this side is 4 and this side is 3. So you can apply the Pythagoras theorem to find this diagonal length, which is 4 squared plus 3 squared, square root of the answer. So we get the magnitude, this one as 4 squared plus 3 squared, square root of this. And you can find the angle. Angle is tan theta, opposite, which is 3. This distance is 3. And adjacent is 4. So you can find theta taking the tan inverse of this. It's only you feel now. Are you okay with this?
Yeah, that's all right.
Okay, so we have done the first one. Now let's look at the second one. So x component is 2 and y component is negative 3. So x component is 2, y component is negative 3. So our vector should be like this. So we can find the magnitude of the vector now with using the Pythagoras theorem again. So that will be 3 squared plus 2 squared, square root of this. So this will be the magnitude of this one, and this will be the magnitude of this. You can either find the angle with the x or y, it doesn't matter. So you can find this angle opposite over the adjacent, tan alpha. You can find that. Opposite is 3 3 over 2. So you can find the alpha as tan inverse 2 or 3 over. Next one is, are you okay so far, Phil?
Yeah, all right.
Can you try the next one?
Yeah, no, I've already,
Already done?
it's just to the southwest.
Yes, yes. So it's like this, right?
Yeah.
Yes, so you can find the magnitude again, easy. So that will be 2 squared plus 5 squared, square root of that, that will be your magnitude. And if this angle is beta, it's okay to
Root
find that.
29.
What's that?
I said it's the root 29.
Oh. Okay, so 2 over 5, so beta is tan inverse 2 over 5. So you can find that as well. I have the solutions, let me see. For the first one, it is 5 units and 37 degrees. For the second one, I got 3.6 units and 56.
Oh, root 13. Oh, okay. Yeah, my calculator reads differently.
If your angle is other side, that's okay. 90
Mhm.
minus angle, it's fine. Then you have to write it in that way, from the negative y-axis in the clockwise direction. Sorry, in the counterclockwise direction. So these are the answers. Are you okay with this one?
Yes. Yeah.
Okay, so the next time we have addition and subtraction. We did something like this today. So can I give you a few minutes for you to try this?
All right.
They have given the vectors in Cartesian form, so you need to add them keeping like that. Your answer also should be in the Cartesian form.
Okay.
When you finish, let me know, okay?
I finished.
Okay, so let's see. The first one I got 14i plus 9j.
Yes.
Second one is the same.
The
because
same. Yeah.
Yes. So, but when you do the minus, you get
6 minus 3 or 6i minus 3j.
Right. So they're asking you to find the magnitude and the direction as well. So how do you find the magnitude and the direction of these ones now?
Same way as we did before. The
Yes.
magnitude is
14
just with
squared plus-
Pythagoras.
Yes, you use the Pythagoras theorem to find the magnitude. The direction is y divided by x. That gives you y, the angle with the x. So you can, your 14, 9 will be like this. So if you find this theta, that will be your 9 divided by 14, which is 33 degrees. Here you have 6 and 3, it's like this. Again, if you find the angle here, that will be tan alpha, which is equals to again 3 over 6. So alpha is tan inverse 3 over 6, but now from the positive x-axis in the clockwise direction. This one from the positive x-axis in the counterclockwise direction. If you always take y over x to find the angle, it is always giving the angle from the x-axis. But if you do x divided by y, x component divided by y component, then it gives you the angle with the from the y-axis. Get used to one method so that you always following the same method. Are we good?
Yeah, good so far.
Okay. So this is right. Yeah, this is similar to the previous one. Yeah, but if you can try this if you want, it doesn't take much time. All the questions are similar now. So you need to keep attention to this negative sign. You have a negative x component in one of these now. So when you add them, I got 5i plus 4j, sorry, 4i plus 4j. When I minus it, I got 8i minus 10j. Do you get the same?
Yes.
Again, we can do the same steps to find the angle and the magnitude. Okay, now in this one, they are asking us to divide the forces into two components and write these two as in the Cartesian form. Can you try to do this one? Maybe we can finish with this one, so I don't want to keep you long. Just we'll do this one, and I think the rest is, yeah, this is what I have already. Yes, so that they are all Cartesian. If you do one, you will be fine. So just convert these two to components and then make it to Cartesian form. So 12. So 12 and 7. So x component and the y component. So we can write x component as, sorry, this is x and this is y. So x component of 12 is a negative x. Did you see that? It is negative x because this one will be like this. So it is 12 cos 55 because the angle is known towards the x side. And y is a positive one, 12 sine 55. This one, 7, again a negative x component, 7 cos 32, and y component also negative. See, it's like this. So it is a negative 7 sine 32. So we can find these values now. 6.88. This is 6.88 negative. So 12 sine 55 is 9.83. And then we have 7 cos 32, which is 5.94 negative. And we have 7 sine 32, which is negative 3.74. So you can write this one as negative 6.88i plus 9.83j. So that's how you write it in the Cartesian form, this vector. This vector also you can write in the Cartesian form, which is 5.94i minus 3.71j. So that is that. The resultant you can find just by adding the x components together. So that will be negative 6.88, negative 5.94 times I plus 9.83 minus 3.71. That's what they are. So it's not that all are connected. So when we understand that components, it's not hard to understand the Cartesian formula. So this is negative 12.82i plus 9.83 minus 3.71, so which is 6.12j. Did you get that?
Yes. Yeah.
Yeah, so yeah, so that's it. All are similar now. See, these questions you got before as well. So if you take one question, you can do the same question with the component method, vector diagram method, and the Cartesian method as well. So those are the 3 things we did. If you are okay with that. And the next thing is vector subtraction. So when you have 3 vectors, don't go for the vector diagram method, do the component method, because it is easier with the component method, doing the questions with the component method. Okay, so please try the questions by yourself. There are a lot of questions. We didn't do all the questions, and let me know if you need any help.
Okay.
I will see you next week then.
Okay, I'll see you next week. Thank you.